and I worked with Manasvi over this last summer to develop this course. We are currently interning with Collaberry, and they have been great. We are grateful for them to give us an opportunity to present you this course. We really hope that you will enjoy this particular course. The structure of the course would look in the following manner. You will first have a pre-workshop wherein we will introduce autonomous vehicles and machine learning. Following that, the main workshop would include how you go about creating a reward function, what exactly is reinforcement learning, things of that sort. And finally, a post workshop wherein we will present some tools, some in-depth things which will help you create better reward functions and better models.
Yep. Thank you so much for that, Yash. So yes, guys, as Yash just pointed out, we'll be going through three parts of this workshop. One is pre-workshop, then the workshop, and then finally post-workshop. Before we begin, would Ram like to say a few words, and then we can begin?
Can you hear me okay?
Yes, Ram.
All right. Hello, everyone. My name is Ram. I'm the CEO of Collaberry. So this is welcome to the workshop. This is a workshop that's being put together by our data scientists and in collaboration with our interns, Manasvi and Yash. So this workshop should give you a idea around how the machine learning fundamentals and reinforcement learning fundamentals. And also it should give you an idea about the modeling around autonomous vehicle. So basically what we developed this in collaboration with Amazon Robotics. And this is typically a workshop that is done in physical world where small vehicles are being programmed and run on tracks. But because of the COVID, all these workshops have gone, we have converted them into virtual workshops. So which is great because we are able to run these workshops even in India. From here, we don't have to like bring the equipment to run it, but you can run it in a simulated environment. So that's the biggest advantage of it. So take advantage of it, learn how to do autonomous vehicle programming using reinforcement learning. And also at the end of the workshop, you will be getting a digital badge that you could use as part of your resume. And then Manasvi and Yash will also show you how to participate in leagues, worldwide leagues, in case if you are interested to continue participating and enjoy. So have fun with the workshop and good luck.
Thank you for that, Ram. Thank you for that introduction, and thank you for helping us out in terms of understanding what all things we'll be learning today in this workshop. So look, guys, let's begin without any wait and any other delay. So there is if you go into the Zoom group chat, we have shared a link with you, which will directly take you to the Refactored website, which is the website I'm sharing right now on the screen. So why don't you guys go to the website and register yourself? And in case you have already registered by this time, please let me know in the chat that you've already registered and we can then proceed. So I'll give you exactly about like 5 minutes of your time. And once we are done with it, please let me know in the chat that you guys have finished registering on the website and you are on the same page where I am right now, which is the which is the workshop called the AWS DeepRacer. Thank you, Pawan, for your feedback. Everybody else has? There are a few questions. Which email should we use? You can use your personal email ID, or you can use your study email ID. That's fine.
Uh,
Yeah, we will share.
Manas, can I pitch in?
Yeah, sure.
Yeah, Manas, let me invite Dr. Ravi Gujula, CGM Technical from APSDC. Sir, is it audible, sir?
Yeah, Jagan.
Yes, sir. Just have a few words about this program, sir.
Okay, so how many students are there?
Uh, now we have 91
91. Okay.
out of 200, 250.
Okay. So this is a totally second batch, right?
Yeah. Just now, a few words are talked about the Ram also, about his program.
Okay. Okay. So who are the yes is there?
Yes, yes,
Yes.
and
Okay.
Hello, Dr. Ravi. I am
Yeah.
there along with Ram as well as Manasvi.
Okay. Okay. Yeah. Yeah. Good morning, all. Really, it's great to see the second workshop. In the first workshop, I think I was not there at the time. Some other activities. So we got a very good feedback for this AWS DeepRacer workshop, which is organized by Collaborate team. So first of all, let me thanks to the Collaborate team conducting a very good program in the form of DeepRacer. So dear students, APSSDC rigorously conducting so many online training programs. Apart from that, this is a very interesting program. It's first of its kind, DeepRacer. So the main objective of initiating this program, there are benefits for the students by participating in AWS DeepRacer workshop. So the participants could able to learn the things like Python, cloud APIs, and statistics, and other analytical techniques. And guys, the students, you regularly, the learning and practice is entirely different when you're going through the DeepRacer. So DeepRacer is the one program where you can get actually the fundamentals and how to implement it towards to the application oriented point of view. That's where Collaborate team expertise that will helps a lot to learn the new things. So in future, there are so many programs like this we are going to implement and collaborating with different companies. And today, I would like to share with the students, AP government signed an MOU with the UiPath to teach students, to train students on RPA, robotic process automation. So it's a big company collaborated with AP State Skill Development. We are very soon we are going to launch robotic process automation in all engineering colleges. Yeah, so I request all the students. It's a very important time. I don't want to take much time. Just I would like to say a few points about the importance of this one. So by participating AWS DeepRacer, where you learn the basic fundamentals and how to implement in application oriented point of view. So at the end of this workshop, you will get a certificate, and also you will get the digital badges that will be linked to LinkedIn profile. So that will directly fetch us to your account. And yeah, so thanks to Ram, thanks to Yash, and thanks to Manasvi and other teammates of Collaborate, interestingly conducting DeepRacer workshop for Andhra Pradesh State engineering students. Yeah, thank you very much. Please go ahead.
Yep. Thank you, Dr. Ravi. Thank you for the opportunity.
Yeah, Jagan, take it forward.
yeah. Let me hand out to Manas, sir. He'll take care of it.
Thank you, Jagan, for handing me over And before we move ahead, I just also want to have a small introduction from Karun, who's also a teammate at Kolibri, and he'd love to talk to you guys. So Karun, why don't you give your introduction as well?
Hi everyone. Hey, I'm Karun. I'm the project manager at Kolibri. Manasvi and Yash and Ram, we all work together. I'm also from Geetham University. Okay, so how many of you are in Geetham? Can you put it on the chart?
Everyone.
Everyone is from Geetham?
Almost all everyone,
Nice.
sir.
Nice, that's pretty good. So I did my electronics and communication in Geetham. I came to US in I finished in '96. I came to US in 2001, and since then I was here. And Ram and me were close friends back in India before after my engineering, and yeah, that's how I landed here. And yeah, I just wanted to welcome you all who are in Geetham. I like that college. The path to the college is really good. The faculty is really good, and my time there, I enjoyed every bit of it. We still have, I think, 2 years back, we had a Geetham Union, which happened in Dallas, Texas. So most of us went there, and all my engineering friends, we met after almost 20 years here. So we had a blast. So these 4 years, what you're spending, actually you'll make lifetime friends. So, I'm glad that you're part of this AWS DeepRacer. Go to refactor.ai. There are a couple of other courses you can learn on your own. There are Python courses, there are statistic courses you can learn on your own. Nowadays, you have to be on learning curve all the time. Even now, me, Manasvi, Yash, and Ram, we keep on learning. So learning is a must in the generation right now. So every day is a college for us. So keep learning. We give all the resources for you guys to learn. So use that. We work hard to give these resources. So please use that. And have fun, everyone. Thank you.
Thank you, Karun, for your introduction, as well as I also feel missed out because it's like you guys already have a gang over here, and I'm one of the odd ones out. But that's not a problem. Let's begin with our workshop. Is Yeah, okay, thank you. So there was a query about a server error, but it's worked out, so we are good. So guys, please let me know, have you finished with your registration in the chat? I just heard, like, read few of you guys reply onto the chat that you have finished registering onto the website. Whoso has not reply now, please let me know in the chat. So cool. It seems a lot of you guys have already completed it. Next up, we need to make sure for the pre-workshop is that you have your AWS accounts set up. So you guys have, do you have your AWS account set up? Also let me know in the chat that you guys have completed that part as well. So yes, it seems everybody has more or less everything set up. Can you use your personal email? I'd say use the email wherein you can get the code, because when you register to Refactored, you get a email verification code. So just make sure that it's the same one. You can choose whichever one you want. And let's begin then. So first and foremost, let's go and have a small introduction into machine learning and also autonomous vehicles, and how reinforcement learning exactly functions or fits into autonomous vehicles. So I will play a video for you guys. Why don't you just sit back and take in as much information as you want from it, as well as in case you guys have any questions for me, straight up ask your question in the chat, and I will cater to those questions once the video is over. So have a great one. Let me just first make sure that I have my video optimized, screen sharing. Just give me a second. Yep, I think now we are good. Yes. Are you guys able to see my screen? Can any one of you reply? Awesome. Let's go.
Welcome to Colaberry AWS. Welcome to Colaberry AWS DeepRacer workshop. In this video, we will get a background of autonomous vehicles, understand the developments taking place, and the challenges that this technology field faces. Autonomous vehicles are a hot topic, with several traditional automotive manufacturers and tech companies entering the fray to develop these vehicles. Autonomous vehicles are capable of sensing the environment, processing the sensory information, and finally make a decision. In the first image, we can see the autonomous vehicle by Uber. There are a number of sensors on this vehicle: a LiDAR unit on top, stereo cameras on the side and rear, and front-facing cameras, to name a few. Visual and informational data is analyzed on an onboard computing system. Many autonomous vehicles are capable of making use of cloud GIS data and to also communicate with other vehicles and infrastructure, like traffic signal lights. Research organizations like SAE have defined the scale of automation of driving experience. On the leftmost side, the driver performs all of the functions, and on the rightmost side, the vehicle is capable of performing all driving functions. Do you know how far we have advanced and where we are now? You will be surprised to know that we are already in stage 3. Several cities are allowing tech players to rigorously test their vehicles, and I had the opportunity to ride in an Aptiv car last year while visiting Las Vegas. It was an interesting glimpse into the future of autonomous driving. In this slide, we will see different clusters of players active in developing autonomous vehicles. Traditional manufacturers like GM and Ford are represented through their acquisitions, Cruise by GM and Argo by Ford. There are app-based taxi services like Lyft and Uber in the same block. You can also see Tesla, Lucid Motors, and Proton Motors in the block below. Let us look at some of the challenges which need to be overcome. All of these technological advances cost a lot of money and drive up the price of vehicles. Also increasingly, users prefer taxi services like Lyft or Uber, as driving feels more and more like a chore. With advances in public commute systems, which have become more convenient and timely, many people can avoid owning a car. The bigger challenge is of a regulatory nature. Autonomous vehicles are coming under increasing scrutiny due to the potential of mishaps occurring. The technological players are increasingly testing their algorithms and codes rigorously. Towards the end, governments and industry want to provide the user a safe and comfortable traveling experience. This workshop serves to introduce you to machine learning and use it in the field of autonomous vehicles traveling a track in a virtual setup.
So guys, we just finished with our first video, which was an introduction to autonomous vehicles. Let us move on to the next one, which is an introduction to machine learning. And let's see how reinforcement learning fits in machine learning and what all aspects of reinforcement learning we can learn from this video.
Welcome to Colaberry AWS DeepRacer workshop. In this video, we are going to learn about machine learning and a few cases of application of machine learning for real-world problems. Machine learning is a subset of artificial intelligence. Through machine learning algorithms, computing systems can automatically learn by experiencing the scenario over and over again. Although there are several classifications under machine learning, the main ones are reinforcement learning, supervised learning, and unsupervised learning. Machine learning is increasingly being applied to a variety of problems, from fraud detection to market pricing. Our first case relates to inventory optimization, which is ensuring that the right amount of inventory is manufactured and priced. Industrial firms collect vast amounts of raw data like promotional campaign funds and types, prices of raw materials with lead times, and so on. Models can be created to understand correlation of different variables, as well as generate useful and actionable insights. Dannon, the dairy product manufacturer, has used machine learning to model demand and forecast spends. This was done by taking data points for various variables to get these insights. As the image shows, Dannon found across-the-board improvements doing this. Machine learning is also useful for computer vision. Computer vision can be used for many applications, including gait analysis and rehabilitation. Visual data from cameras is used along with footwear to analyze the gait or walking motion of individuals. A control system provides signals to an exoskeleton that will be used for rehabilitation of an individual. Reinforcement learning can be used to train a robot system to solve a Rubik's Cube. Let us watch this video now.
We're trying to build robots that learn, a little bit like humans do, by trial and error. What we've done is train an algorithm to solve the Rubik's Cube one-handed with a robotic hand, which is actually pretty hard even for a human to do. We don't tell it how the hand needs to move the cube in order to get there. The particular friction that's on the fingers, how easy it is to turn the faces on the cube, what the gravity, what the weight of the cube is, all of these things, it needs to learn by itself. The interesting thing is that kind of standard techniques in robotics haven't been able to scale to that complexity that we see in a robotic hand. Humans have evolved to be able to manipulate and operate our hands. So there's a huge amount of learning that's happened through evolution to get us to this point as a species. And the robot has to learn all of this from scratch. Instead of trying to write very dedicated algorithms to operate such a hand, we took a different approach where we create thousands of different simulated environments and learn to do the task in all of those, and hopefully a robotic hand will be able to do it in the real world as well. This means like thousands of years of experience that this neural network has had in simulation. Every time the algorithm has gotten good at the task, we make the task harder. That's really crucial because it needs exposure to really complicated environments in order to eventually be robust to the real world. You put a rubber glove on the hand and can still carry out the task. This ability to generalize to new environments feels like a very core piece of intelligence. It really changes the way we think about training general-purpose robots. Moving from thinking too much about the actual algorithms and start thinking about how do we create complex enough worlds where they can learn. At some point, then it would be more down to the imagination what robots could actually accomplish. The hope is to build robots that can do many different tasks, to increase the standard of living and give everybody a better life.
The following modules will further elaborate on reinforcement learning and usage in AWS DeepRacer.
All right, so we finished with our very basic first two videos, which kind of just gives us an overview about what machine learning is, very little about it, as well as very little about what reinforcement learning is. So these videos were primarily to help you guys understand that wherein we are trying to go, what kinds of application machine learning as well as reinforcement learning is used at, as well as kind of leeways into our next topic, which is the workshop itself, wherein we will learn about what reinforcement learning is, how it is formulated, what are the important crux behind it, as well as your questions, whichever if you have right now, you can let me know in the chat. And we'll go through them, all of these questions of yours, and then we can learn more throughout this process as well as learn from each other. So let's go back and we go on to our workshop and we begin with the basics of reinforcement learning. By the way, before I begin this video, I would like to share with you guys the fact that on refactor.ai website, everything which I'm teaching to you right now is also present in a non-workshop format as well, wherein we have notebooks for each and every one of you. You guys can go to our website, check them out. Everything we'll teach you today is also present offline for you guys. So let's just go and you can have a look about everything. All steps are there, every detailed fashion about what reinforcement learning is, what machine learning is. It's all present on our website. You guys can go and finish it on your own whenever you'd like to go about and do it. So other than just the AWS DeepRacer, we also have data science courses on our website. So in case you want to go and just check them out on your own, you guys can go and check these modules out on yourself and complete them and learn a lot from our website. So let's begin with the basics of reinforcement learning and what it is all about. In case you have a question for me, you guys can write your questions in the chat. I would recommend all of you guys to go on mute during the session so that we do not disturb anybody else. And yep, let's begin.
Welcome to the Colaberry AWS workshop video. In this video, we will learn about what machine learning is, the different types of machine learning, and also the related reinforcement learning. Additionally, we will check out basic computer science functions and some neural networks, but these will be optional and featured at the end of the video. Machine learning is defined as a subset of artificial intelligence in which machines find patterns and provide predictions without being explicitly programmed to do so. More specifically, it is a subset of artificial intelligence that includes any techniques which enable computers to mimic human intelligence. A subset of machine learning is deep learning, which is based on neural networks that permits a machine to train itself to perform a task. Now, let us watch a video to understand machine learning and the various different types of machine learning.
Machine learning is guiding artificial intelligence capabilities. Image classification, recommendation systems, and AI in gaming are popular uses of machine learning capabilities in our everyday lives. If we break down machine learning further, we find that these three machine learning examples are powered by different types of machine learning. Image classification comes from supervised learning. Recommendation systems comes from unsupervised learning. Gaming AI comes from reinforcement learning. How can we better understand supervised, unsupervised, and reinforcement learning? Let's start with supervised learning, which makes up most of the uses for machine learning today. In supervised learning, the machine already knows the output of the algorithms before it starts working on it. The algorithm is thought through a training data set that guides the machine, and the machine works out the steps from input to output. Supervised learning is used for image classification or identity fraud detection and for weather forecasting. But how is unsupervised learning different? Well, first off, with unsupervised learning, the system does not have any concrete data sets. And the outcomes are also mostly unknown. Now, when you log on to Hulu or Netflix, you have personalized recommendations because of unsupervised learning. And lastly, there's reinforcement learning. Reinforcement learning is different because it gives a high degree of control to software agents and machines, which are determining what the behavior within the context should be. People are helping the machine to grow by maximizing performance, providing feedback to the machine, helping it to learn its behavior. Reinforcement learning requires the use of tons of different algorithms, giving control to the agent as they decide the best action based on the current results. When you are gaming on PC, Xbox, PlayStation or Nintendo, and you witness AI in gaming, This is because of reinforcement learning. Now that we understand supervised, unsupervised, and reinforcement learning by breaking down machine learning, what are some applications of these forms of machine learning? Look at these examples of supervised learning. And check out these examples of unsupervised learning. And here are some examples of reinforcement learning. Applications for machine learning are endless and constantly expanding. Thank you for joining me.
We will now talk about reinforcement learning. Reinforcement learning is defined as a machine learning technique where an agent, which is the component that is responsible for making decisions, explores its environment to learn how to perform desired tasks by taking actions with predefined good outcomes and avoiding actions with predefined bad outcomes. A reinforcement learning model will learn from its experiences and over time will be able to identify which actions lead to the best rewards. Let us look at simple examples to build on the understanding of reinforcement learning. Reinforcement means the process of encouraging or establishing a belief or pattern of behavior, especially by encouragement or reward. Let us use the example of training dogs. A dog learns by associating actions, such as bringing back a toy to its owner, with getting a reward, such as verbal praise, like good dog. Another example would be of a maze. You are the agent who is trying to complete the maze, which is the environment. Walking is the action that you perform on this environment. The nearer we are to the maze exit, the more confident we are that we are making the right decisions. This acts as a reward. The agent tries to perform the action in such a way that the reward is maximized. This is how reinforcement learning works in a nutshell. In reinforcement learning, an agent interacts with an environment with an objective to maximize its total reward. The agent takes an action based on the environment state, and the environment returns the reward and the next state. The agent learns from trial and error, initially taking random actions, and over time identifying the actions that lead to long-term rewards. In this diagram, I represents the current state, and I plus 1 would represent the next state or the next future step. An example would be at time I, we have the agent performing an action, AI, based on its present state, SI, and reward, RI. Based on this action, the agent have moved to a new location in the environment, I plus 1, which in turn gives it the feedback of the reward, RI plus 1, in the new state, SI plus 1. Now we will give a quick recap of the major points we've covered in this video, which were: machine learning is defined as a subset of artificial intelligence in which machines find patterns and provide predictions without being explicitly programmed to do so. That there are 3 types of machine learning: supervised, unsupervised, and reinforcement. Then, in reinforcement learning, an agent interacts with an environment with an objective to maximize its total reward. The agent takes an action based on the environment state, and the environment returns the reward and the next state. The agent learns from trial and error, initially taking random actions and over time identifying the actions that lead to long-term rewards. Now, we will learn about functions in Python. These are optional in case you already know the basics of Python programming and functions. A function is a block of code that executes in a sequence and can be invoked in a repeated fashion. In Python, as in other languages, users can define their own set of functions such that a set of statements can be invoked multiple times from other parts of the program. There are various parts to a Python function which are taught in depth on the Python for Data Scientists course presented at the Refactored AI website. We would recommend you to visit the course and select the Libraries and Functions module to learn more. The last topic of this video is neural networks. Let us see what a neural network is and how it functions.
When you or I look at this creature, we know it's a dog. But when a computer sees him, all it sees is this. How do I get a computer to recognize that this photo, or this one, or that one, is a photo of a dog?
It turns out that the only reliable way to solve this problem is to give the computer lots of examples and have it figure out on its own the average, the numbers that really represent a dog.
Here's where deep learning comes in. As you might recall, it's a program based on the way your brain works. And it looks something like this. Here we have layers of sensors or nodes. Each feeds information in one direction, from input to output. The input layer is kind of like your retina, the part of your eye that senses light and color. In the case of this photo of Buddy, it senses dark over there, light over here. This information gets fed to the next layer, which can recognize basic features, like edges. That then goes to the next layer, which recognizes more complex features, like shapes. Finally, based on all of this, the output layer labels the image as either dog or not dog. But here's the kicker, and this is what's revolutionary about deep learning and neural networks. At first, the computer has no idea what it's looking at. It just responds randomly. But each time it gets a wrong answer,
information flows backwards through the network saying, you got the answer wrong. So anybody who is supporting that answer, your connection strength should get a bit weaker.
And anybody who is supporting the right answer, their connections get stronger. Back and forth, it does this over and over again. Until, thousands of images later, the computer teaches itself the features that define dogginess.
All right, so guys, we finished with our basics of reinforcement learning. And what we kind of want you guys to gain from this video is primarily this diagram over here with us. So this is how exactly a reinforcement learning model kind of works, wherein an agent, which is our DeepRacer, or you could say the race car, which we are trying to simulate, or which we are trying to finally race against each other, is the agent. It takes an action. What would you mean by action? An action would be either going forward, slowing down, speeding up, or taking a left turn, or taking a right turn, right? Very basic things which that car can do. And then we have our environment in front of us. So our agent takes an action onto the environment, which is pretty simple, straightforward. Environment is our track, our racing track. So initially, when our model or our race car starts training itself, what it does is that it takes a random action based on the input it is getting from the environment. So it sees, for example, a straight road. So first time it tries taking maybe a left turn. So what it sees is it get two things as feedback from the environment. What are those two things from, what are those two feedback? So first and foremost, one thing is a reward and the other one is a state. So by state, what I mean is whenever the agent takes an action on the environment, it goes on to a new state. So for example, if it was going straight, like if it saw a straight track, but it was trying something new, so it took a left turn, it'll see that it has gone off the track. So that's the new state, right? So that acts as one feedback, and the other feedback is the reward function, which we have stated, or which we as the people who are designing this or making the code have put it as a backend. And a reward function typically is something which gives breadcrumbs kind of a feeling, or just rewards the model or our DeepRacer on to things which it should do, what kind of a behavior it should do and follow. So that is what exactly a reward function does. It does not hard code it to do something. For example, if it sees a left turn, take a left turn. If it sees a right turn, take a right turn. It's not like that. It's meant to be a generalized function wherein it should reward correct behavior, which would over here just be maybe stay on the track. So even if the car took a left turn but was still on the track, so our reward function might give it some points, you can say. But if we make a very strict reward function, you can also say if it went off the track, it'll give our model no points. So this is how our model is kind of remembering things, or by trial and error, it is trying to gauge how its actions will lead to either a high amount of reward or no reward. So slowly by each trial and error, maybe first time it takes a left when it sees a straight road, so that gives it makes it go off the track, right? So it gives us no reward. So now it knows that, okay, this is a wrong action which it is doing right now. So next time maybe it'll try going straight. So next time when it saw a straight track, it started going straight. And it saw that, yes, it is still on track. And our reward function, because of it doing the correct thing, gave it points. So now it has learned from this fact, from this trial and error, that in case it keeps going straight on a straight track, it'll keep on accumulating reward. And that it is exactly what it's trying to do. We will go right now into our workshop, but we will also go through what exactly that reward function is and how we can play about with it. Also, before we go, in case you guys have any questions, let me know in the chat right now, and as well as please make sure that you have your AWS consoles opened up on your end on a new tab, and let's begin. So this video will primarily talk about model initialization on the AWS DeepRacer console, which is the AWS DeepRacer website. So just make sure that you're logged into AWS, and the initial part of the video will talk about you going through the root user settings. You do not have to worry about that fact, because you guys already have I think your student accounts, if I'm not wrong, with AWS, or your personal accounts, I do not know. But just make sure that you guys are on the AWS console website, and then we can proceed exactly the same steps.
Hello, racers, and welcome to your first AWS DeepRacer model building guide. Before we begin, please make sure you have an AWS account and an associated email ID.
Also, guys, I would like to re-emphasize that this part of the video will ask you to do certain steps so as to create your first model. I will keep pausing this video in the middle and keep asking you whether you guys have been able to follow along till that point. I'll keep pausing and maybe replay some part of the video for you guys so as to you guys can follow us properly and everybody comes along together. So just let me know in the chat if you have been able to follow until this point of time. So let me know, are you guys able to follow what we have been trying to do till this point of time? Please let me know in the chat. Cool, good, awesome. So let's begin with our model initialization part.
If you do not have that, we would recommend you to create one using the link below. Let's begin. This is the login page for AWS. Here we select the root user option and enter your AWS associated email address. Click Next and then enter your password. Now that we have logged into the AWS Management Console, our first step is to make sure we have the right server set up for the AWS DeepRacer. This can be done by taking our mouse pointer to the top right corner and selecting N Virginia or the US East 1 server. After picking the correct server, we have to find the DeepRacer service on AWS. We will type DeepRacer into the Find Services box. We will then select that and proceed.
Okay, so I'm pausing the video first time over here. Have you guys been able to follow along till this point? Got the right server set up as well as type DeepRacer on the Find Services button? Please let me know in the chat. Have you guys been able to follow until this point? I see one yes, no. Please repeat. Sure, sure. So what we have to do is that please make sure that you are on to the AWS Management Console. I think you post which on the top right hand side of the screen, you'll see your server. You need to make sure that it is US East 1. Let me replay that video for you once again. But yep, let us go.
Right server setup for the AWS DeepRacer. This can be done by taking our mouse pointer to the top right corner and selecting N Virginia or the US East 1 server. After picking the correct server, we have to find the DeepRacer service on AWS. We will type DeepRacer into the Find Services box. We will then select that and proceed. All right, so now we are at the DeepRacer service landing page, wherein we can find everything related to DeepRacer. We recommend you to watch the videos as well as read the documentation present on the page, as it will help you to understand a lot more about the AWS DeepRacer product, its events, and the technology behind it. However, let's now start with our model building process. On the left side of the web page, you will see a topic called Reinforcement Learning, and below that, you will see the option of Get Started. Click on this. We will be directed to the model building web page of the AWS DeepRacer, which will show us an overview of the AWS DeepRacer. This talks about the journey you will take with the AWS DeepRacer project, beginning by learning about reinforcement learning and resulting in you competing in the DeepRacer leagues. Next, we will skip part 1 and go towards part 2.
I would also like to pause here for a moment. So I just need you guys to make sure that everybody's on the same page, and I see a few questions about can I repeat. So you just need to make sure that you have the correct server setup, which is on the top right side of the screen. Then find AWS DeepRacer onto the Find Services, and then you guys can reach onto this page and select Begin creating a model. Let me also reiterate the fact that this video is present on our website on Refactored, so you guys can anytime also go back and watch these videos on your own. And in case right now you are unable to follow or you think you missed out on a certain part, everything has been listed on our website as screenshots for you guys to select and do and follow the instructions. So you're not going to miss out on anything because we have the whole workshop for you guys on our website. You can watch these videos on your own, as well as presently, in case you feel if you're missing out on something, you guys can directly go to the notebook and also see what is missing in case there's something. Your question I see is we are on AWS Educate account. So yes, that should not be a problem. Please proceed with your AWS Educate account. And somebody is saying it's asking for a credit card number. So I think you should have your AWS Educate account. So go through that. Do not use your personal email ID or your personal login for the AWS console. So yeah, I'd recommend that. So let me continue with the video. And yep, so we need to make sure that we are a create a model and race. Where in Educate account can we do the things that you're saying? So I think in your Educate account also you can find DeepRacer, because last time also I had the APSSDC workshop, people were able to find it. You can go to Find Services on your AWS Educate account and just find AWS DeepRacer. Has anybody been able to follow us at least till this step? Please let me know in the chat. All right. So I do have a few people who are still, I think stuck at a certain step. Do not worry about it because we have everything ready for you on our website. If you have registered on Refactored, you should be able to go back and see all these pointers as well as all these steps as well as the video. So do not worry, you can see it on your own. But right now, due to the benefit of time, we need to make sure that we complete the workshop on time. We'll proceed with the video.
Part 2 is the Create a Model and Race step. Select Create Model. This page lets us into the nitty-gritty of our back-end reinforcement model. Next, we give the model a name. We would recommend in the future that you select an appropriate name according to the approach that you would like to build your reward function, but for now, we will proceed with Test Model 1. We would also recommend writing a complete description of the approach you take in creating the reward function in the model description space. For now, we will just type, "This is our first AWS DeepRacer model." Next, what we have is the environment simulation piece. The environment contains a track that defines where the agent, here our DeepRacer, can go and what state it can be in. The DeepRacer explores the environment to collect data to train the underlying neural network. To begin with, we will take a simple model such as the reInvent 2018 track. One quick tip here. The more complicated your track is, the faster your model learns. Why do you think so? You can let us know in the comments below. So now we will proceed and select the reInvent 2018 track and scroll down. Next, we will select Next.
Are you guys able to follow until this point? You have selected the track as well as just given your model a name. Please let me know in the comments if you guys have been able to follow until this step. I would wait at least 5 minutes for you guys. Like not exactly 5 minutes, about a minute or two, because it's a pretty simple, straightforward steps. And I'll replay the video for you guys, like a quick recap, and then we'll proceed with the next part. I think that should be fine and make sure that everybody's on the same page. So I'll go back to the point where we start building a model. So which is get started with reinforcement learning. So here we go.
We will be directed to the model building webpage of the AWS DeepRacer, which will show us an overview of the AWS DeepRacer. This talks about the journey you will take with the AWS DeepRacer project, beginning by learning about reinforcement learning and resulting in you competing in the DeepRacer leagues. Next, we will skip part 1 and go towards part 2. Part 2 is the Create a Model and Race step. Select Create Model. This page lets us into the nitty-gritty of our back-end reinforcement model. Next, we give the model a name. We would recommend in the future that you select an appropriate name according to the approach that you would like to build your reward function, but for now, we will proceed with Test Model 1. We would also recommend writing a complete description of the approach you take in creating the reward function in the model description space. For now, we will just type, "This is our first AWS DeepRacer model." Next, what we have is the environment simulation piece. The environment contains a track that defines where the agent, here our DeepRacer, can go and what state it can be in. The DeepRacer explores the environment to collect data to train the underlying neural network. To begin with, we will take a simple model such as the reInvent 2018 track. One quick tip here. The more complicated your track is, the faster your model learns. Why do you think so? You can let us know in the comments below. So now we will proceed and select the reInvent 2018 track and scroll down. Next, we will select Next and move on to the next page. Now we are looking at the page which displays the race type. This is where we can select either a time trial, object avoidance, or head-to-head racing. As we move on from time trial to head-to-head racing, the complexity of the problem increases, as well as the resources required. Why do you think that is? Again, let us know in the comments section. Next, we will have to select our agent, which is our vehicle. For now, we will select the basic version called the original DeepRacer. Remember, this vehicle is also configurable separately, but for now, we will select the default and proceed. Now, we reach the most important part of this guide and the place which can help you achieve the fastest lap. What you're seeing on your screen right now is the reward function. The reward function describes immediate feedback as a score for reward or penalty when the vehicle takes an action to move from a given position on the track to a new position. Its purpose is to encourage the vehicle to make moves along the track to reach its destination quickly. The model training process will attempt to find a policy which maximizes the average total reward the vehicle experiences. This code is completely editable. We would recommend you to play around with this code a lot while you train multiple versions of your DeepRacer model. There are certain preset models which are provided by AWS, but feel free to experiment as well. You can check out these presets if you select the reward function examples. In case you do edit the reward function, you can check whether the code syntax is correct or not by clicking on validate.
All right, so let me take a small pause here because I think we covered a lot of steps and just talk a little bit about reward function and what do we have to do with it on the AWS DeepRacer. So let me just ask you guys a question. Do you guys know how to code in Python? You can let me know in the chat. Like very simple Python code. That's awesome. See, so you guys, most of you guys do know how to code in Python, but this workshop also helps you guys out in terms of making it easier. So what you guys can do on the AWS console is you can select different reward function examples. You can just go onto their website, look at the different type of reward function examples, which you, if you think that might, another one might be a better option, and then you can also play along with them. And these numbers which you see on the screen, these are just reward numbers. You can play along with them and tweak them so as to make better fine-tuned reward functions. So yes, so that's what you can do. But for now, just stick with the default reward function because this is a tutorial workshop for you guys. So we'll just be taking a small, simple reward function for now. But later on, once you guys are developing better models or highly accurate ones with the advanced reward functions which are present on our post workshop material, you guys can go ahead and play along with all of this code and tweak it as you think it's necessary. So have you guys been able to follow until this step? Please let me know in the chat. All right, so I see a few yes. Let's continue.
For now, we will select the default function and scroll down. We can now see the training algorithm and hyperparameters. Hyperparameters are variables to control your reinforcement learning training. They can be tuned to optimize the training time and model performance. For our first model, we will let the parameters remain in their default state and proceed. Scrolling down, we see the stop conditions. The training of your model will stop when the specified criteria is met. When your model has stopped training, you will be able to clone your model and start training again using new parameters. We set it to be 5 minutes for this tutorial, but would recommend at least 30 minutes for each model you make in the future. Then click on Next.
All right, so as you guys saw in this video right now, we kind of just glanced over hyperparameters as well as stop conditions. So hyperparameters, as you guys might be knowing, is small tuning factors which can play a very important role on how fast your model trains as well as what the performance of the model altogether. So we have not talked a lot about it in our workshop, that what exactly these hyperparameters are and how you can play with them. But on our post workshop material, we have them explained throughout in complete detailed fashion. The way reason we have not done it for this workshop is because I believe, as much as I've learned from hyperparameters, it's a whole topic in itself, and that will take this workshop to get extended by about like 2 hours or something. So we need to make sure that this workshop is done in due time. So right now, I would still expect you guys to just select the default parameters, hyperparameters, and proceed. Do not play around with them. But you guys can read more about them, get a lot more detailed questions, or in case you guys want to ask me or my team some questions on these hyperparameters, you can mail us or you can ask us in the comment section post the workshop. Next up, what I wanted to talk to you guys is the stop condition. So in reinforcement learning models, what you have to do is you have to ask, yeah, if it's asking for you for a league racer name, you can just make one league racer name for yourself. It should be just keep it something which is like your name or something. Your first name underscore last name should work for you guys. Anyways, coming back to stop conditions. So we need to make sure that in reinforcement learning model, we give our model a track or an environment for it to learn from. So we need to give it specific amount of time wherein it can learn. So we can give it from 5 minutes to 60 minutes to 3 hours to maybe 12 hours. So the longer training time we give it, it'll learn more about the environment and would have tried out new things and become a very solid, or you can say overfitted model. So you need to make sure your stop time is optimized. For DeepRacer, I would recommend you guys to put in maybe 1 hour of training time or something. But for this workshop, please make sure that you have only 5 minutes worth of training time. So make sure that your stop condition has 5 minutes as your training time. We'll go through the fact that we are giving it such short amount of training time, so our model will not perform well because it's a first model. But this workshop is primarily to help you guys understand that yes, that this is how you proceed with creating an AWS DeepRacer model. So do not worry, in case you return and want to create an advanced model, you guys can change the stop time from 5 minutes to 60 minutes or maybe 2 hours. But I would recommend never go beyond 2 hours of training time, or I would say more than 1.5 hours of training time. So please make sure that you guys have followed till this point. Just select 5 minutes of your training time and then go and select create model. Great. So have you guys been able to follow till this step? Please let me know in the chat. I see one yes. Have others been able to follow till this step? I see a query. There isn't anything like stop condition. So it should be present on the bottom left of your screen or somewhere, wherein if you are at the model initialization part, let me share it with you 1 second. So this is my own DeepRacer. If I go over here and follow the steps which I've just shared along with you guys, give me a moment. Is my screen clear now? Should we click create model at the end? Yes, please select create model. but just make sure that you have 5 minutes in your stop condition. So yeah, so if I go to get started and then I go to create model and something, I just quickly go on next step. Yeah, so it should be right here like this. Please make sure that you have unselected this part, automatically submit to DeepRacer League. That's not required for you guys. So in case you have it collected, that's also fine. That should not be an issue, but just make sure that you have 5 minutes over here in your stop conditions, and then you go and select create model. All right. So have you guys been able to follow me until this point? Please let me know in chat. Yes, so for your league racer name, you can just put your first name underscore second name, like last name. Should be fine. And all right, so I think you guys have started training your first AWS DeepRacer model, and I think it should have started populating in terms of a new page for you guys. So let it train for 5 minutes, but it will start creating a simulated environment for you guys, then train for 5 minutes and then stop that simulated environment. So this will take at least 10 minutes. So I have already set 60 minutes, sir. So I think you can stop it explicitly. If you have started it for 60 minutes, you should see on the top right hand side a button to stop it. So you can just stop it and then go back and just train for 5 minutes for now. I would recommend that. So yes, so right now we are completed with almost halfway of our workshop. So let us take a 10-minute break wherein you guys can stretch a little, have some water, and while your model is training. And in case you guys have a question for me, please let me know in the chat. I'll be here for you guys. But let me see you guys in exactly 10 minutes. It's 8:53 a.m. for me. But I'll be back in, we'll start back in 10 minutes. So that'll be 9:03 a.m. for me. So I'll just put it out for you guys right now. 10-minute break. Would be a problem, as Yash has also pointed out. If anyone has started training the model for 60 minutes, should not be a problem. Just remember that steps need to be done after the model is trained. That's right. So we will continue with our with our workshop. Do not feel that you're going to get left behind or anything of that sort, because we have everything on our website on Refactored. You can come back and follow the next steps on your own. Do not worry about it. But yeah, I would say select only 5 minutes and go ahead with it. All right, so I'll see you guys in 10 minutes. In case you have that question, more questions, let me know in the chat. Thank you. And I'm still here for your questions. I'll wait for another minute for everybody to join back in, and then we'll begin. Please let me know in case you have any questions. All right, so now we had already put a model to train. Let's see what exactly is happening with our model training, as well as see how our model evaluates in terms of how well it does after whatever training time it has been allotted. So let's begin with our next video. I'll also take small pauses in the middle so as to make sure that everybody's on the same page. But in case you have any questions, let me know in the chat.
Now we are training our model. On the top side of the screen, we can see the training is being initialized. So right now, AWS is allocating resources for the model and we'll start training our model. This is a time-consuming process, hence we would recommend you to pause the video and wait until you start seeing a simulation video on the screen. Now we can see how our model is training. We can see the reward graph as well as the simulation video stream. Both of these changes over time as our model runs. We would recommend you spend the time to take note of the graph and its labels, as this gives you a good idea of how fast your model is learning and can save you a lot of future training hours. This simulation will run until the set stops time. After a brief while, the reward graph will start populating, and we can see after multiple iterations, our model earns more and more reward and also increases its average percentage completion of the training track each time. This goes to show that our model is taking feedback from the environment and learning what actions to take at a particular state. The longer we let our model train, the better our model will be. After this, our training is complete and we can evaluate our model. So next we select Start Evaluation. To evaluate our model, we need to set evaluation criteria. First, we are asked to select the track where we want to evaluate our model. We can choose to select the same track we let our model run, or choose a new track to see how robust or flexible our model is to change. Right now, we will select the same track, which is the reInvent 2018, to evaluate our model. We also will scroll down and select the same race type, which is the time trial. We skip the virtual race submission for now, as we are just running our first model. Later, once we have better models, we can choose to submit them right away to virtual races. Next, we click on Start Evaluation.
All right, so this is the first point where I've taken a pause. Have you guys been able to follow until this point? Please let me know in the chat. All right, so all right, we can go back to from the start a little bit. It's a small part of it, so don't worry about it. But yep, let's repeat it, and please make sure you guys follow every part. And once we are post this point, we'll proceed.
Now we are training our model. On the top side of the screen, we can see the training is being initialized. So right now, AWS is allocating resources for the model and we'll start training our model. This is a time-consuming process, hence we would recommend you to pause the video and wait until you start seeing a simulation video on the screen. Now we can see how our model is training. We can see the reward graph as well as the simulation video stream. Both of these changes over time as our model runs. We would recommend you spend the time to take note of the graph and its labels, as this gives you a good idea of how fast your model is learning and can save you a lot of future training hours. This simulation will run until the set stops time. After a brief while, the reward graph will start populating, and we can see after multiple iterations, our model earns more and more reward and also increases its average percentage completion of the training track each time. This goes to show that our model is taking feedback from the environment and learning what actions to take at a particular state. The longer we let our model train, the better our model will be.
All right, so I received a question in chat, which is the reward graph same or different for everyone? So as this is a neural network based problem statement wherein on the back end, it's a neural network working out. So we will more or less have different type of reward graphs. I mean, a little bit same, but not exactly a replica between two separate models. It might differ from person to person, from machine to machine, because as neural network starts off randomly, it takes random steps, random action spaces, randomly it is trying new things. For example, it sees a straight track. Your model might take a left turn, my model might take a right turn, or the third model might go straight. So the third model will immediately learn that it has done the right step and or the right thing to do. So it will start learning a bit faster, whereas in my and the second person's model, it might take some time. So there might be slight differences between every reward graph, even if we have the same reward function at the back end of it. So do not worry about the fact. Also, we will go through a small video on reward graphs, which explain what exactly it is and how we should use it. So do not worry about the fact. Let's just make sure that the steps which we have to follow right now are being followed. We will recap onto our reward graphs and see how exactly they function and what information we can gain from them. So let me continue.
After this, our training is complete and we can evaluate our model. So next we select Start Evaluation. To evaluate our model, we need to set evaluation criteria. First, we are asked to select the track where we want to evaluate our model. We can choose to select the same track we let our model run, or choose a new track to see how robust or flexible our model is to change. Right now, we will select the same track, which is the reInvent 2018, to evaluate our model. We also will scroll down and select the same race type, which is the time trial. We skip the virtual race submission for now, as we are just running our first model. Later, once we have better models, we can choose to submit them right away to virtual races. Next, we click on Start Evaluation. This will start our model evaluation, as well as start a model stream, which will show us how exactly our model is working on a test environment. Note that this is a model testing, hence the model is not learning anything here. It is just applying what it has learned on the training exercises. The evaluation results will start populating, as well as show how many trials, as well as how much time and percentage of the track completed per trial that our model was able to perform. Also now would be a good idea to note down the driving pattern of the model, as we can identify certain driving characteristics which we will want to improve on over the next iterations. An example could be if there's a very zigzag pattern in the steering of the model, we could counter it by introducing a change in the reward function, which penalizes rapid switch in steering patterns.
I also got a question like start evaluation is not blinking for me. So do not worry. I think that's primarily because AWS console might be shutting down services in terms of closing the simulated environment. So don't worry, it'll come online for you in a minute or so, or within 5 minutes. It sometimes takes time, so do not worry about it. In case you feel that you're getting left behind, I would say just watch the video along with us, and you can follow these steps post the workshop as well. So don't worry. You guys have been able to follow until this step as of now. Please let me know in the chat. Great. So I think you guys have also selected start evaluation. So you'll see these values starting getting populated, which is your evaluation result. This might take 5 minutes or more because it's again setting up a simulated environment. So let me just give you this reason why AWS console takes so much time of learning and stuff and like closing and opening the environment. So you need to realize that in a simulated environment, AWS is creating your robo racer, a track, like a simulated track, which has all the nature, all the features of regular physics, like a physical world, like we have, like gravity, and all these things have to be simulated. So it's a huge task for a computer, or you can say for any server to set up or generate that environment. So that's the reason why it takes a lot of resources, and that's the reason why it takes time for it to set it up as well as shut it down. So that is something which it might take some time, about 5 to 10 minutes. So do not worry about that fact that it is taking time or it is still running. It does that. You can be lucky that it stops and gets completed in a minute, or you might have to wait for 10 minutes or 15 minutes. But do not worry about the fact that there's something extraordinary happening or anything of that sort, or you have to be concerned about it. It's just that it takes time. Do not worry about it. I got another question that after starting evaluation, which criteria we need to select in terms of starting evaluation, which criteria? So yes, the criteria, if I'm not wrong, you have to choose a racing type, if I'm not wrong. So yes, please select the time trial one, as well as for the environment, you can select any one of the tracks, but I would recommend that you select the track which you trained on, which is the reInvent 2018 one. So that's the one which I recommend you guys to take. But yeah, you can select any other one as well. But yeah, that's the deal with it. So yep. So have you guys been able to follow until this point? Do you see any evaluation results popping up? Has anybody any results? Can anybody tell me how much percentage completion have they achieved in the chat? Anybody else got any percentage completion or anything of that sort? I only see one reply, 30%, 17%, yep, 4%. All right, so so nothing to worry about that fact that either your evaluation is not filled in up, like it's not displayed yet, or for few people it's like 30%, 17%, 4%, 2%. That's only because of the fact that you gave it only 5 minutes of training time. So you need to realize that reinforcement learning models take a lot of time to train, because they literally are like small kids who are learning to walk, as an example. So you can just imagine that how much it has to give a trial and error kind of a way, wherein it has to see so many things. The first time it will see a left turn, what will it do? The first time it sees a right turn, what will it do? All these things come into picture. So it takes a lot of time. That's why I said once you are training your own models, like advanced models, you can give them things like a longer training time. Give it an hour and a half, or 2 hours of training time. As well as you can talk about, you can do things like train on a difficult track. So for example, if I took just the oval track or the circular track, so literally the machine is just learning to go around in circle. It's not seeing something new every time it does an action, primarily after like initial few tries. But if you give it a very tough circuit wherein there's a lot of left right turns and some short straights, some long straights, and all these things, it'll learn faster, because it'll also go through these experiences, right? How we as humans also learn new skills and stuff by increasing the difficulty of the things which we're trying to learn. Same is the case with the computers as well as the machines as well. You give it a difficult track to learn from. Initially it might struggle, but but it'll learn faster as well. So you can do these small things to fix or increase the performance of your training. All these things which I'm talking to you guys about is present on our post-workshop material. I will share it with you guys right now, but I would recommend you guys that once this workshop is done, please go onto our website on Refactored and go through all these advanced training material, because it will actually legitimately make you a really good racer, as well as you guys can then compete internationally, get like prizes from AWS, and yeah, like there's no limit for you guys to do anything post that. So let me continue from this point onwards in the video, and let's go ahead and let me know in case you guys have any questions.
Which shows exactly how our model is running on the test environment. This shows us how we're able to. While the model begins its evaluation, we're able to see the video stream, which shows exactly how our model is running on the test environment. This shows us how our model is implementing what it has learned over the training period. On the right side of the screen, we can now see the various evaluation metrics and our model performance. Even though we have very poor results, that is because of the extremely short training time we allowed our model to learn. If you allow the model to train for more than an hour, you will see much better results. So now we have completed this guide for creating your very first AWS DeepRacer model. Here's a recap of some of the things that we have learned. First, We now know how to access and navigate within the AWS DeepRacer console. Second, we identified the steps that go into building a model in the AWS DeepRacer console. Third, we now know how to use the basic reward function within the DeepRacer to configure a model. And finally, we use the DeepRacer simulator to train and evaluate our model. As this was your first attempt, you can only get better and faster with more practice and more advanced reward functions. Good luck and keep racing with Colaberry and AWS.
I see many people have started sharing that they have got 15%, 5%. Who else have their results out? Has anybody got more than 30%? Anybody got lucky? Anything of that sort? Let me know in the chat. 9%, 68%. That's nice. You legitimately got a lot lucky. But that might also be true that you gave it a little bit more of training time. So yeah, so don't worry guys, this was just your first model and you just like dipping your hands into the waters of reinforcement learning, if you might say. And that's the very reason it's not doing a very great job of completing the track. But the more training time you give it, the better it will do. So next up, let's talk about what we were saying initially is interpreting the reward graph, right? We saw the reward graph. What exactly is it about? So we have a video on it and let's go through it. Welcome to the Colaberry Welcome to the Colaberry AWS workshop video on reward graphs. In this video, we will learn about what a reward graph is and how it is created. Additionally, we will check out reward graph metrics and how to use reward graphs on AWS DeepRacer. In AWS DeepRacer, after you start training the model, you can examine the training metrics of the reward and track completion per episode to determine the training job's performance of your model. On the AWS DeepRacer console, the metrics are displayed in the reward graph. There are three metrics which are displayed on the reward graph. First, the average reward per iteration. Second, progress per episode. And third, average progress per iteration. You can choose to view the reward gain per episode, the average reward per iteration, the progress per episode, the average progress per iteration, or any combination of them using the toggle. The range of rewards is shown on the left side of the graph and the range of progress, 0 to 100, is on the right-hand side. To read the exact value of a training metric, we move the mouse near to the data point on the graph. Next, let us talk about how the reward graph is created. In AWS DeepRacer, leverages Amazon SageMaker to train your model behind the scenes and uses AWS RoboMaker to simulate the model and the agent's interaction with the environment. Next, let us learn about the reward graph metrics. First, the best model line allows you to see which of your model iteration has the highest average progress during the evaluation. The checkpoint for this iteration will be stored. A checkpoint is a snapshot of a model that is captured after each training iteration. Second is our reward. It is primarily on the y-axis shown, and the reward graph is earned during a training iteration. To read the exact value of a reward, we hover our mouse over the data point on the graph. Our third metric is the percentage track completion. It is shown on the secondary y-axis and it shows you the percentage of the track the agent completed during a training iteration. Now, iteration, which is on the x-axis, is the number of iterations completed during your training job. Our fifth metric is the average reward, and the average reward is what the agent earns during the training iteration. The average is calculated by averaging the reward earned across all episodes in the training iteration.
As defined, an episode or run begins at the starting line and ends when the agent completes one loop around the track or at the place where the vehicle left the track or collided with an object. Our sixth metric is the average percentage completion, and this is during the training phase. This is the average percentage of the track completed by the agent in all training episodes in the current training iteration. Our seventh metric is the average percentage completion during evaluation. This is the average percentage of the track completed by the agent in all episodes run during the evaluation period, while SageMaker is updating the model using the current iteration of your model. Now, in our final section of the video, we will learn how to use the reward graph in the AWS DeepRacer. It is essential to use reward graph as a good indicator for, first, the training time of our model, and second, the robustness of our training model. Let's talk about these. How do we determine the training time of our model? A good indicator of when to stop the training of the model can be determined by watching the graph. It has likely converged if the progress per episode continuously maxes out or reaches 100% and the reward levels out. This indicates that we should stop training. This can be seen in the example graph. After about 400 iterations, all the three metrics do not improve significantly. Hence, it would be a good idea to either stop training the model after 600 iterations because none of the metrics are improving anymore. Another reason to stop the model after it achieves 100% track completion is because continuing training will cause overfitting in the model. An overly trained model won't perform well in a real world or new tracks because it cannot handle even minor variation between the simulated track and the real track. To check for the robustness of a model, typically the reward graph should rise in value initially and then plateau later. When the graph of the metrics are near the previous values after plateauing, it means the model has learned in a well-defined way and would perform consistently on multiple runs during the model testing phase. In case the values tend to fluctuate drastically or never reach a plateau shape, this means that the model either needs more training time or is very volatile, thus requiring either a change in the reward function or tuning of hyperparameters. With this, we have reached the end of this video and learned what a reward graph is and what information we can gain from it. Thank you. All right, so I got a question from Pawan, I think. So we ran all the same code. So is it all about how lucky we are with the rand function? So it's not exactly the rand function, I would say. It's about the randomness of a neural network, which kind of let's say take any sort of action initially. So like I said, that your model might do the right thing first right off the bat, and my might take a few wrong steps initially and then do the right step. So that's the only reason why there might be a separate percentage completion. Like for example, we can see people ranging from 0% to 68% within just 5 minutes of training time. So you can see it's a lot about you getting lucky as well in terms of how lucky you are, in terms of how short training time you gave and you still are getting very solid results. But in case if everybody gave about 1 hour of training time, I bet it would all be very close. It will then come out to something, I would say 90 to 95%, or maybe 95 to 100%, and everybody's within that range. So because by that amount of time, it has your model has made those many errors, it has tried new things, so it has kind of learned. So this is how neural networks work in terms of our reinforcement model work, because it's trying to find out new areas. So you just give it a lot of training time and then you can just go ahead with it. Next up is, once you have completed this part, we are almost at the end of the workshop, guys. So thank you so much for sticking with me for so long. But you can look at this video on submitting model for a community race. So in case there's a community race taking place, you guys can go ahead and submit your models. We right now are not hosting one for this workshop, but in case you want to, you can watch this video. What I want you guys to do is have a look at our post-workshop notebooks and syllabus which we have for you guys. So it talks about customizable reward function. What you can do is you can go onto this notebook, and in case you do not know how to code in Python, you can create, you can like click on these Jupyter Notebook cells, and it'll create a simulated Python environment for you, wherein it'll be a simple drag and drop, and you can create something like your own final reward function, wherein even if you do not know how to code in Python, you can still work around with it. What else do we have for you guys is that we have videos for reward function, wherein we deep dive into what exactly a reward function is, wherein small places wherein you can make a lot of progress and what things you can learn out of it. So I would recommend you guys to watch that video. Same with hyperparameters. For hyperparameters, we have a video, as well as in case you go for advanced reward function and hyperparameters, we have a huge notebook for you guys, wherein we talk about all small parameters you guys can play around with, as well as what the top leaders across the globe are doing, what kind of models are they building. So in case if I scroll down, you can see these are reward functions which people have created over a lot of time with a lot of practice and a lot of efforts. So you guys can learn from these, try them on your own, or change them, tailor make them for yourself, try or test them out and see how well you can do, or if you can better their time. So there's a lot of things you can do, as well as you can play around with things called action spaces for the robot, wherein you can play around with things like if you want to increase the speed of the robot and all these things. For now, coming back to our workshop, I would recommend you guys to go to the final quiz, because we require you to finish the final quiz so as to earn that badge, the AWS Colaberi DeepRacer badge. In case you want that badge, I want you guys to finish the quiz. I'll give you guys exactly 5 minutes for you guys to finish the quiz. It's a very small, simple quiz. Do not worry about the fact whether you got all right answers or all wrong answers. It's more about you attempting the quiz, because once you're done with the quiz, we'll go through the questions and answers. We'll learn what's the right question, what's the right answer, and we'll discuss about it as well. So don't worry about it. I'm not going to click on it because it'll start showing up my answers to you guys. But I want you guys to go on to the final quiz and complete it right now. And once you've completed the quiz, please let me know in the chat that you have completed the quiz. I'll wait for 5 minutes for you guys. So yes, please go ahead. Thank you. Hey guys, I've just got one response as of now who has completed the quiz. It's mandatory for you guys to complete the quiz so as to get the badge. So please let me know in the chat once you finish the quiz. All right, I hope you guys have completed the quiz. I would also be very appreciative of the fact in case you guys can also fill in the survey, which is right beneath the quiz. So you guys can just go sign in with your Google accounts and please finish the survey. It will be really helpful for us so that we can make sure that next of our events for your peers and your friends is a better experience. We are trying to learn as much as we can, as well as trying to make a course which is tailor-made for you guys and wherein you guys can come in, learn as much as possible within the smallest amount of time, and also let us know what you feel about it. So please go ahead and fill in the survey for us because it's very important for us. But let's go through the quiz results. So not the results in the sense, the answers. The first one is in DeepRacer reinforcement learning model. The objective of the agent is to maximize the reward because it's a greedy algorithm. It's trying to eat as many points as possible, if you want to say. And then next is what type of learning is utilized in training the DeepRacer. It's reinforcement learning. Then the question is which factor ensures, and remember the word ensures, that the model you have trained gives better results for the DeepRacer. So you can think things like lots of training data, a small car and wide track. These are correct answers as well, I would say, but do they ensure that it'll give you better results? That's not true. What ensures is an optimized reward function and not all of the above as well. Next up is when the agent leaves the dash, it is called an dash. So you should get that when the agent leaves the environment wherein it either crashes or takes a turn which it has completed, but it takes it off the track, it completes an episode, and multiple episodes is what is required for our DeepRacer to train itself so as to do the right thing. And once it reaches an episode wherein it completes the whole track, that is a successful episode for us. And then final question is how can you reduce model training time on DeepRacer? So I know this is a little out of the box question because we have not talked about it, but you can do all of these things, which is reducing the number of epochs and training the model using a GPU instead, and choosing a simpler track or a challenge, and all of the above. So all of the above would get you reduced training time and hopefully like that, it's not necessary, but hopefully a better result as well. So yep, so these are the answers. But with this, I hope you guys have completed the survey. But with this, we have completed our workshop. We have gone through all the basic training required for running our first AWS DeepRacer model. What's the basic things regarding reinforcement learning. And yep, we have come towards an end for our workshop. Thank you so much. Thank you guys so much for staying with me so late during your evening hours. And I hope you guys learned something or gained something out from it. And I would love to know more questions from you guys in case if you want to reach out to me via email, or you can reach out to Yash as well. My email ID is pretty simple. It's my name at colaberry.com. Let me write it in the chat for you guys so you guys can just can reach out to me anytime you guys want. And thank you so much for your time. And do let me know in case you have any questions. But with this, we have come to an end of our workshop. So in case you guys want to leave or have completed your model training and everything, you guys can leave. And thank you so much for your time. Have a good evening. And in case you have any questions, me and Yash will stay here for at least 5 to 10 more minutes and take your questions. But yep, I think it's good. And thank you so much. I have received a question, how do we access our badge? So once you have completed your training, I mean, not the training, I mean your quiz, you have completed your quiz, we will have your email addresses in the backend server. So we will be sending across those badges to you on your email IDs. So do not worry, you'll receive them in a week or two. I hope that answers your question. Is there any other question anybody else has? When will you receive the certificate? Yes, so it's the same thing. Within 2 weeks after you've completed the quiz, we'll have your email addresses, we'll send them across to you. It'd be really helpful if you guys can fill in the survey. It's very important for us, and it'll help us improve our class. So please please fill in the survey. But yes, guys, so we have completed our workshop. In case you guys want to continue with your day, you guys can leave. And thank you so much for your time. If we give the APS, yeah, so you will receive the badge on your APSS email ID. You'll receive it on that. Do not worry. Thank you, Jami. You will receive the certificate on the email through which you have registered on Refactored on this website. I would also recommend you guys to go on to Refactored website and check out so many courses which we have for you guys. Try out different topics and stuff. 1 second, let me take you guys there. Yep. Go to library and you can find all these amazing modules which we have ready for you guys, which is pandas, numpy, plotly. These are small micro courses, and you can also go for bigger courses, something like web scraping, SVMs, tree methods, unsupervised learning, model selection, database SQL, Python for data scientists, and we have our data science programs as well. So you should, and it's all free for you guys. You can just go in and learn as much as you want and at any time. So do not worry about it. Just go and explore our website out, learn as much as you can want. And in case you have any questions or doubts or concerns, you can email us or reach out to us on your own. So that's not a problem. I received a question. The name might be quite different there. Can we change the name? I think what you can do is drop us an email that you want your name changed, and hopefully we can get it fixed for you guys in the back end. Yep. mail ID to which we need to mail. You do not need to, okay, so mail ID for you to mail. So yes, you can reach out to me or Yash. We have put in our email addresses up, which is deepracer@collaborate.com. You can reach out to that email. The account that we registered with the APSSDC credential, how long is that valid, sir, to access your courses? It's fine. It's fully accessible, as well as you can just create a new account from your personal email ID in case you want. So do not worry about it. So just go ahead and access it anytime you want from your APSSDC, or you can access it from your personal account. Just create one, and as much as I know, it's all open and free of cost for you guys. So just do it. Don't worry about the fact. And another question which I have is, how do we access our badge? We will be sending out the badge to you on your email addresses, registered email addresses. All right, so me and Yash will stay for 2 more minutes, and then I think we can close this meeting. Does anybody have any other questions? So if a model is not trained completely, if we come back, it gives us any problem. So in case it's not completed training, so if by not completed training, what would you mean in terms of, is it still training, or you gave it a very short amount of training time? By problem as such, there's nothing called, I won't say there's as such problem. What I would say is, if you give it a very short amount of training time, it would not have, evaluation in progress, you mean. So yeah, so it's not, even if it's evaluating in progress, then it means it's testing out the model. So do not worry about it, that will give you as such problems. But yeah, just give it a little longer training time later when you do this this whole thing again on your own. It should be fine. Next is, sir, getting errors while creating model. Sometimes it might happen that you get small errors, but in case you missed out on a small detail, I would recommend you go to our course, the AWS DeepRacer, and then look at a step-by-step guide wherein we have written down, like put in screenshots on how you should proceed with the model creation. Maybe that should help, and it'll fix all of your errors. Track info could not be fetched is the error. Oh, okay. So that might be an error from the AWS end of it. So do not worry. I would, yeah. So sometimes AWS also has problems from its own side. Just give it some time and retry. It should work in some time. All right. So with this, me and Yash have come to an end to this workshop, and I think we'll leave. And thank you so much once again for your time, guys. And hope you have a nice evening. And I hope you guys were able to learn a lot. And I again would recommend you guys to go ahead and use our website, refactor.ai, and learn as much as you want. And all of this is free and open for you guys. So just go ahead and learn as much as you want in your free time. With this,
Thank you, everyone.
Yep. Thank you, Yash. All right, guys. Have a good day. Bye-bye.
Bye.
Thank you, Ash. Thank you, Manish.
Thank you, Jagan.
Thank you all.